Hello and welcome to today's daily Leetcode challenge. Today we'll be solving question 91, Decode Ways. It's a medium level question. Let's get into the description. A message containing letters A through Z can be encoded into the numbers using following mapping. And the mapping goes, it's pretty easy, from A to 1, Z to 26. 26 is the number of characters in the English alphabet, and so it's just a one-to-one mapping. To decode an encoded message, this is the opposite, the inverse operation. All digits must be grouped and mapped back into the letters using the reverse of the mapping above. So from 1, we would get A, from 2, we get B, and so on until 26 getting Z. However, there's a caveat. There are multiple ways to do this. For example, 11106 can be mapped into, can be grouped first into 11106 and then 111006, which would give us completely different results. There's some notes that, for example, 11106 is invalid because 06 cannot be a string, cannot be something that we use. And then string S contains only digits, return the number of decode. Given that S contains only digits, return the number of ways to decode it. Okay, so let's see. There's some examples here of how the 12 can be represented as a 12 itself, which is an L, or a 1, 2, which gives us AB. 226 could either be 22 and 6, could either be 226, or it could either be 2, 2, 6. So we get output 3. So we don't actually need to decode, we just need to show how many different ways there are to do this. This looks like a dynamic programming problem where we consider the input string from right to left and figure out at each point how many different ways can we represent this, or how many different ways we can collect a valid grouping. For example, if we were to start from the right, from the 6 here, we know that the only possible way to group the input array of length 6 is 1. So we would have something like this. We would have, let's start with an empty DP array that represents the number of ways to group starting from any specific point in the input array. From 6, there's only, if we were to only be considering the character 6 or the digit 6, there's only one way to do this. Now, if we were to start considering 2, 6, well now you can see that the number of ways to group 2, 6 is a combination of some prior knowledge, which is what other ways is there to just group the previous array, not including the array that has the digit 2 in it, which is 1. Then we have another additional caveat, is that there is a potential for 2 digits together to be representing one character, right? So then we have another increment, and then that's it, right? So let me actually let's see, can I simplify this even more? No, I can't. Let me get some of these initial structures of a dynamic programming solution up. For I, and I want a range of length s minus 1, because I'm actually going to be saying dp minus 1 is equal to 1. Okay, so this is what I was thinking. dp of my current position is basically just equal to dp of I plus, and this could just be, this could just be this. However, there's this caveat that if int si I plus 2 is greater or equal to 26, then I also want to consider dp to be dp I plus 2. Yeah. And then return dp of 0, dynamic programming array of 0. So what is this structure indicating? Well, I have a data structure as just a regular list that represents a single thing, right? It represents what is the number of valid ways to group a subarray starting from where I'm starting at. So in this case, in the case of the 226, the initial array is going to be of length 3, and each one of these positions represents how many different valid ways, so how many different valid ways to group subarrays starting at current index. How many different valid ways to group a subarray starting from current index. So if I was to be looking at this, and the input string looks like 226, looking at this index, the question that I'm answering is how many different ways to group a valid array consisting of just 6. And the answer to that is pretty obviously, even to someone that's not a computer, the answer is 1. The answer is 1. How does this go about in code? Well, this is kind of a given that in a DP array, the last integer, actually, if this was a 0, this wouldn't work, right? But the last is always equal to 1. So we have dp of -1 is equal to 1. Cool. What is this loop doing here? I'm going to now be iterating through the rest of my dp array, starting from 1 minus the last index. That's why I have the range of length s minus 1, and then reversed. So I'm going to be going from right to left. Now, what is this step? For the index second to last, this is my question that I'm answering, right? Same question. How many different ways to validly group array starting from the 2? I know that I could simply include this 2 as its own element, which would leave the previous, which would leave the number of ways to do a proper grouping just this number here. Why is that? Well, if 2 is being omitted from contributing to the different ways to group the later part of the subarray, then the number of ways to group is just the previous number of ways to group, right? This subarray. So this is just going to be adopting the one here, the previous subarray valid grouping. However, there is a caveat, right? That there's a valid way to represent a group that is of 2 characters. So 26 is actually also a valid one. And this is what I'm doing here. I'm checking that if from s of I to I plus 2 is less than 26, so is less than or equal to 26, so basically is a valid potential grouping, then also append, then also add to this number what would have been here. And actually, yeah, this could be like a 1 here. Although I'm probably not going to be able to get away with doing that. Let me do this. If I stumble on a case where the last two input digits create a valid mapping, then I have to consider that as a valid mapping. So the number that I'm going to be adding to the current valid grouping numbers is just 1, as opposed to what this would have been if we were considering something that doesn't end on the last digit. And then I have okay, well, let's see if this works. Oh, and this is probably not going to 2 digits. Sorry, 1 second. Okay. Okay, we have everything working except for the instance where the 0 is the first index. Actually, yeah, this is almost like an edge case. Let me say that I can't consider zeros as valid numbers completely, so this is going to work. Okay, let's submit. Oh, and 0 can't be a valid number if s negative does not equal 0. Actually, use this test case. Yeah, so it's a little bit hectic, but dynamic programs are notoriously hard to understand and even more explain. I don't know if I can do a better job describing exactly what I'm thinking, but the idea is you're building up the solution from like the bottommost, the smallest case possible. So if we were to see what that means on some examples, the smallest case, building up the answer from the smallest case would mean that we're starting from 6, and the answer, and it's very easy to answer there, what is the valid number of groupings? It's just 1. Then if you were to consider 26, we can answer that by using the information that we just answered about the 6. Right? We can say that, hey, if we can consider 2 as a valid group, then what did we consider the previous number that we just inputted, 6? We considered that to have 1 valid group. And the 2, 6, therefore, has a potential for 1 valid group, which is just the 2 separated from the 6. However, there's another valid group, which is the 26. So now you have sort of 2 directions. And they conjoin, they aggregate together into the current possible valid groupings in DP. So we consider the one where it's just a single one, and then if the conditions meet, then we add another one to it. Yeah, so I mean that's the solution. Let me submit this one more time just to have a cleaner piece of code. Not doing too well, but I'm pretty sure that the other solutions which have roughly the same approach, just because this is like a typical dynamic programming solution. Yeah, I'm not even going to try to understand that, but I see that they're using the same DP array, so that kind of just gives me the answer to that is the fastest solution. All right, well, actually, let's keep this short one more time. Thanks for watching. I'll see you guys later, and enjoy your holidays. Bye.